Hello students, we've been working in Chapter 5 and we started Section 5.1 last time. Today we're going to work in Section 2. So today's lesson is Section 5.2, which is entitled Factoring Trinomials. Okay, Factoring Trinomials. We're going to start by doing some board work, and I'm going to begin by putting a trinomial onto the board. So let's factor the trinomial x squared plus 7x plus 10. Okay, let me repeat. We're going to factor the trinomial x squared plus 7x plus 10. And remember from yesterday, factor means to express as a product. So we want to try to express this as a product of two smaller polynomials. Well, the only thing we know how to do so far is to take out a common factor. Is there anything that we can take out of these three terms here? Is there any number or any variable that we can pull out from these three terms? Well, if you look at it, there isn't. There isn't anything that we can pull out. So we have to use another technique to factor these type of polynomials. Well, I claim, so I'm going to write down the word, that I claim that this polynomial is equivalent to the product of these two polynomials, x plus 2 and x plus 5. And let's see, is that true? Well, you would want to FOIL this to make sure that that is true. So let's check. X times x is x squared. X times 5 is 5x. X times 2, or 2 times x, is 2x. And 2 times 5 is 10. And if you check it, you have x squared. 5x and 2x are going to give us the 7x, and then 10 at the end. Okay? So in fact, this is the factorization for that polynomial. Now, how can you go from here to here? I just told you that this was the factorization. How do you go from here to here? Well, let's look. 2 and 5 are the key numbers. Why are they the key numbers? Well, because 2 times 5 gives us the last number, 10. These two numbers, when multiplied together, have to give you the last number. These two numbers, when added up together, they give you the middle term, 7x. 5 and 2, when added up, give you the middle term. So, if we were to look at this polynomial and we wanted to factor it on our own, we would first of all look at the 10 and try to think of two numbers that multiply to give us 10, 2 and 5, and then we would check and make sure that those numbers added to give us the middle number, 7x. Okay? So just remember, you want two numbers that give you a product for the last term. So let me just write down product in the last place. And the middle number, you want to have a sum. Okay? So you want the two numbers to give you a sum. So let's do a bunch of examples. Let's factor each of the following polynomials that I'm going to put up. Okay? So examples, factor each polynomial. And in each case, we're going to use the method I just described. So let's take the first example, which I'm going to write as x squared plus 9x plus 20. Okay? Now, what you want to do is you want to look at that polynomial, x squared plus 9x plus 20, and you want to key into the last number first, and you want to find two numbers that multiply to give you 20. So you want two numbers that will multiply to give you 20. Well, let's see. 2 and 10 gives us 20. 1 and 20 give us 20. And 4 and 5 give us 20. Okay? Those are two numbers that will multiply to give us 20. Now, the second step is, once you get those things going in your head, you look at the middle number, and you say, okay, now I need these pairs to add to 9. Well, let's check. 2 plus 10, that's 12. 2 plus 10 is 12. That's not going to work. 2 plus 10 is 12. That one doesn't work, so I'm just going to cross that off. 1 plus 20, that's 21. That one doesn't work either. 4 and 5, however, when you add up 4 and 5, you do get 9. And therefore, 4 and 5 are the numbers that I'm looking for. 4 times 5 will give me 20. 4 plus 5 are going to give me 9. And therefore, I'm going to factor this polynomial as a product of two smaller polynomials, x plus 4 and then x plus 5. And you can double check it by multiplying. X times x is x squared. 5x and 4x is 9x. And 4 times 5 is 20. And that's the correct factorization of x squared plus 9x plus 20. So it's x plus 4 times x plus 5. Let's take a look at a second example. So I'll call this example B. And this is the polynomial x squared plus 11x plus 24. Okay, x squared plus 11x plus 24. Again, you want to take the last number, 24, and you want to try to find two numbers that will multiply to give you 24. But at the same time, you want those numbers to add to give you 11. So let's see. First numbers I think of that multiply to 24 are 6 and 4. But I know they don't add to 11. They add to 10. So they're not going to work. Can we think of another group of numbers that multiply to 24? Oh, how about 3 and 8? 3 times 8 is 24. 3 plus 8 is 11. So that must be my pair of numbers. So I'm going to now write this as a product. This is the product x plus 3 times x plus 8. And again, you can check it. X times x is x squared. That's 8x plus 3x, which will give us 11x. And 8 times 3 is 24. And therefore, the factorization of x squared plus 11x plus 24 is the product of x plus 3 times x plus 8. Okay, let's look at some that have some negative in them, some polynomials with negatives in them. So let's take example C, which is x squared minus 8x plus 12. Okay, x squared minus 8x plus 12. Again, you take the last number, namely 12, and try to think of two numbers that will multiply to 12, but add, this time, to negative 8. You have to worry about that negative sign on there. So, let me tell you what these are going to be. 12, well, I know that if I take negative 6 times negative 2, negative 6 times negative 2, a negative times a negative gives you positive 12. And if I add negative 6 to negative 2, I get negative 8. And therefore, this time, the product has to look like this. X minus 6, right, because of the negative sign on the 6, times x minus 2. And let's check it. X times x is x squared. That's a minus 2x, minus 6x, which is minus 8x. And then minus 6 times minus 2 is positive 12. And therefore that works. Okay? Let's take a look at another one similar to that one. So this is example D. And I'm going to erase this one here and give us some more room. Example D. Let's try the polynomial x squared minus 8x plus 7. X squared minus 8x plus 7. Again, you're going to focus your attention first of all on the last number. And then you're going to look at the middle number. So there are two numbers you're looking at. So you want to find two numbers that multiply to 7 but add to negative 8. And again, because this is positive, you want two negative numbers here because you want the sum to be something negative. So I think, in fact, the only two numbers that will multiply to give you 7 are 7 and 1. And in fact, if you make them both negative, negative 7 and negative 1, they add to negative 8. And so the factorization of x squared minus 8x plus 7 should be x minus 7 times x minus 1. And again, you can check it to be sure, but that is the factorization there for D. Okay, let's take a look at another one that's kind of tricky. And this will be example E. So again, it'll have a negative involved. So let's do example E. And E reads as follows. We're going to take the polynomial x squared minus 8x, x squared minus 8x minus 20. Okay, x squared minus 8x minus 20. Here we go again. We're looking, first of all, at the last number, negative 20. Okay? We want two numbers that will multiply to give us negative 20. So that means one of the numbers must be positive and one of them must be negative. We then want them to also add up to give us negative 8. So let's just check something. If I have negative 4 and positive 5, that gives us negative 20. However, when you combine those or add them up, you get 1. 5 minus 4 is 1. So that doesn't work. Let's see. What other numbers give us negative 20? I could also try negative 5 and positive 4, but again, you're going to see that that doesn't work because that, when added up, gives you negative 1. How about 10 and 2? 10 times 2 is 20. If we make the 10 negative, then we have negative 10 times positive 2, which is negative 20. And if you add negative 10 to positive 2, you in fact get negative 8. All right, so those are the two numbers we're looking for. So let's express this as a product. So I'll come down here and we'll write that as x minus 10 because of the negative 10, and x plus 2 because of the positive 2. And therefore we have x minus 10 times x plus 2. And when you multiply this through, you should get x squared minus 8x minus 20. Okay? That was kind of tricky. Let's do another example like that last one. Okay, where your last number is a negative number. Let's take the polynomial x squared plus 2x. So this is example F. X squared plus 2x minus 15. Okay, x squared plus 2x minus 15. You begin by looking at the minus 15, and you ask yourself, okay, let's think of two numbers that will multiply to give me negative 15. Well, the first numbers that come to mind for me that give you 15 are 5 and 3. 5 times 3 is 15. Now, one of them has to be negative and one of them has to be positive to give us a negative 15. And they have to add up to give us positive 2. So, if we make the 3 negative, I think these two numbers will satisfy those conditions. 5 times negative 3 is negative 15. 5 minus 3, or plus negative 3, is 2. And therefore, we're going to multiply two polynomials, x plus 5 times x minus 3, and that will give us x squared plus 2x minus 15. And I do want to point out, because one of the most common questions I always get is, people will say, well, does it matter which one comes first? No, it doesn't. You can put x minus 3 first, and that is the same answer, okay? Either one works. It doesn't matter what order they are. The only thing that's important is to make sure that the minus sign goes to the 3 and the plus sign goes to the number 5, okay? Okay, let's look at a couple more trinomials. Let's look at example G. And example G reads as follows. Let's do x squared minus 13x plus 36. Okay. So, everyone should try to do that on their own first. Looking at the positive 36, you want two numbers that give you positive 36, and at the same time, we'll combine to give you minus 13. So go through your head, try to come up with some numbers, and I'll let you know that I think that 9 and 4, in fact, they both have to be negative. Negative 9 and negative 4, those two numbers will work because when they multiply, they give you positive 36, and when they add up, they give you negative 13. And so this polynomial should be factored as x squared, or x minus 9 times x minus 4. And that should work there. X minus 9 times x minus 4. And let's look at one more tricky polynomial here. Let's look at h. Let's take the polynomial x squared plus x plus 1. X squared plus x plus 1. Now, let's try to come up with two numbers that will multiply to give us 1 and add to give us this middle number, which is also 1, right? 1x. So, the only two numbers that multiply to give us 1 are 1 and 1. 1 times 1 is 1. But 1 plus 1 is actually 2, right? 1 plus 1 is 2, and that's not 2 in the middle. So those numbers can't work. Well, you could also try negative 1 and negative 1, because negative 1 times negative 1 is 1. But again, when you add them up, you get negative 2, and that doesn't match my middle number 1. So they don't work. In fact, there are no two numbers that will multiply to give me 1 and at the same time add to 1. In other words, you can't factor this polynomial. This polynomial can't be factored. Can't be factored. And in fact, every now and then you're going to find polynomials that can't be factored. So be aware of that. Not everything can be factored. Polynomials that can't be factored are called prime. And that's because, just like with prime numbers, well, prime numbers are numbers that you cannot factor. You cannot express as a product. Same thing with polynomials. If you can't express them as a product, then they are also prime. And let's take a look at one more of these before I do something a little tricky. Let's take a look at something like this, I. Let's look at a polynomial that has multiple variables involved. Let's take a squared plus 10ab, a squared plus 10ab plus 16b squared. Let me repeat. We want a squared plus 10ab plus 16b squared. Now, this one's a little trickier because you don't only have an a squared here, you have another variable involved, the b squared. But for right now, just ignore those two variables and simply focus on your coefficients or your numbers. Look at the 16 and find two numbers that multiply to 16 but add to 10. And let's see, doing them in your head, go through the factors. 1 and 16, 4 and 4. How about 8 and 2? 8 times 2 is 16. 8 plus 2 is 10. They work. So now how are we going to write this product? We're going to start by putting our parentheses down first for product. We know that our first term is an a squared, so this has to be an a, and this has to be an a. And normally now we just put the numbers in here. So I have a plus 8 and I have a plus 2. But you need to get a b squared involved. So you need to make this a b and this a b. And let's check it. A times a is a squared. So let me put that here, a squared. A times 2b is 2ab. 8b times a is 8ab, or 8ba. And 8b times 2b is 16b squared. And in fact, if you check it, 8ab and 2ab is 10ab, and this factorization does give you the correct polynomial. Okay. Okay, that completes the basic factoring for trinomials. In the next section, we're going to look at trinomials similar to this, but they're going to have a lead coefficient on them. So that gets a little trickier. So before we look at those, I want to quickly review what we did yesterday, though, because you will need to use that technique. I want to quickly review factoring by grouping, which is what we did yesterday. So a quick review of factoring by grouping, and that was in section 5.1. And if you remember, you factor by grouping when you have 4-term polynomials. Okay, so let's look at an example here. Let's take the polynomial 12x to the 5th plus 20x squared minus 21x cubed minus 35. Okay? So what? 12x to the 5th plus 20x squared minus 21x cubed minus 35. Now remember, this is a 1, 2, 3, 4-term polynomial, so the technique you want to use to factor these is called factoring by grouping. And the way you do that is you group these two terms together and group these two terms together. Okay? So you're going to group these two terms together, and you're going to put these two terms together, and that negative has to stay with the 21. So I'm going to move it closer to my 21, and I'm going to group those two terms together. And remember, this is just a big polynomial, so I'm just going to put a plus sign because everything's being added up. Okay, after you group, the next step is to factor out the greatest common factor from each pair. So if you look here at the first pair, what's the greatest common factor you can take out? You can take out from the numbers, the greatest number that you can remove is the number 4. And as far as the variables go, you can take an x squared out, 2 x's out. When you do, when you take a 4x squared away from 12x to the 5th, you get a 3x cubed, double check, 4 times 3 is 12, x squared times x cubed is x to the 5th. And when you take a 4x squared out of the 20x squared, you should get 5. Double check, that's 20x squared. And over here, what can you take out? Well, I'm going to take out a negative 7 because I can take a negative number away from both of these. And when I take a negative 7 out, I'm left with positive 3x cubed. And when I take a negative 7 away from there, I'm left with a positive 5. Again, double check. Negative 7 times 3 is negative 21. Negative 7 times 5 is negative 35. So the second step is completed now, where you've factored out from each group. And now the last step is to take out this common term being 3x cubed plus 5. That comes out. So when you take it out from each of these parts, you're left with a 4x squared plus a negative 7, or if you like, minus 7. And therefore, you've completed the factoring of that 4-term polynomial. 3x cubed plus 5 times 4x squared minus 7. Okay? Okay. Review this technique before you come in for tomorrow's lesson or the next section's lesson, because in section 5.3 we're going to use this technique a little more. So I will see you tomorrow then, or in the next time, and we'll look at more factoring. Bye.